I'm Gerd Hammerschmidt, Professor for Public Management at the Center, and it's my big pleasure, and I'm really excited that we today can welcome Oliver Neumann for a presentation and insights from his research. And I think you chose a very attractive title, Oliver, an upgrade from Max Weber's bureaucratic machine, adopting agentic AI in public administration. So really the question, we have this very traditional hierarchical Max Weberian style public administrations. We have this very new ideas of AI, agentic AI, and how do we bring both worlds together? Very often there's the argument that these are very different worlds, but I think the argument of Oliver is that there's a good potential to bring these worlds together. There's much more common than we would assume. And it's really great, Oliver, that you have accepted our invitation. And I'm also very glad, I mean, we have seen a record number of registrations. I think we have 240 registrations, so we never had an as demanded research colloquium series ever. So you're a record breaker for us, Oliver. Fantastic that you're here. Very short introduction about Oliver, and we really should spend most of the time about his presentation discussing with him. Oliver Neumann is a professor in the Swiss Graduate School of Public Administration. That's IDEA at the University of Lausanne, which is a well-renowned kind of research hub for public administration research. He received his PhD in management at the University of Bern, which is also in Switzerland one of the central hubs of public management research. And he also worked as a postdoctoral researcher in Bern. And I think his research very nicely brings together research on IT, information systems, but also classical public administration research, behavioral public administration, digital transformation, public sector information, and now most recently, of course, AI. But I know also you have published on Agile, so a lot of the hottest topics we have running around in the field of public administration. You're doing really exciting research, and it's fantastic that you're here with us, Oliver. And I will pass over to you in a moment. Just wanted to shortly mention the format. So the idea is, and we have asked for Oliver for a presentation of about half an hour, maybe a little bit longer, but not the full hour, so that we still would have sufficient time for questions, discussion. So this is also a key idea of this research colloquium, not just lectures, but having interaction, exchange, discussion. And for that, as we are a very large community, very large group, I would ask all of us for quite a strong discipline. So please mute your phone. When you have a question at the end, signal that with the hands up signal. I would then give you the voice, and then you switch on your microphone and can raise your question. Also would ask all of you shortly, if you come up with a question, shortly mention who you are, and then also ask you to have a short question and not a very lengthy co-talk, but more a short question that we can have really possibility to have many of you involved in this interaction and discussion. And of course, you also can put your questions into the chat, and we will check that and bring forward some of the questions to Oliver in this kind. And with this, Oliver, I pass over to you. Great pleasure again. Thanks for accepting our invitation. And I also forgot, we will record the session, but we will record only the presentation. The discussion later on will not be recorded. So, and we have Chatham House rules in this research colloquium. Oliver,
Perfect.
passing over to you. Great that you're here with us.
Thank you so much, Gerd, for the kind introduction. I couldn't have done it better myself, so I'll jump right into the topic. It's great to be here. This is, I think, my first talk at Hertie School, but I'm, of course, quite familiar with what you're doing over there. Your institute is a bit larger than ours, so it's great to have this exchange between our two countries and institutes. So my talk today, Gerd has already touched upon it a little bit, is on Max Weber's bureaucratic machine, and I've entitled my presentation today in a bit of a provocative way, I guess, an upgrade for Max Weber's bureaucratic machine, adopting agentic AI in public administration. Now, many of you, I heard there's a lot of students from Hertie who are in this session, will be familiar with Max Weber's bureaucratic machine, but I will still go over some of the key principles in the beginning before I will then talk about agentic AI, what it is, and what challenges and opportunities exist in terms of adopting agentic AI in public administrations. I've also brought a few emerging examples. To be perfectly honest, there is not a lot out there at the moment, but there are a few examples in various stages of development and deployment that I would like to go over with you. And I have a few concluding remarks and brought also some possible avenues for future research before we move to the Q&A session in the end. So beginning with Max Weber, he had this core idea in his work that bureaucracy is the most rational form of organization, and it's grounded in rational legal authority. And when you read his original texts, he often referred to the bureaucracy or the state and its rational bureaucracy as a mechanism, a machine, or an apparatus. And that was, of course, just an analogy. It wasn't an actual apparatus as the one that I've showed here on the introductory slide, which, by the way, is a piece of kinetic art by Swiss artist Jean Tinguely. It's actually moving. I don't have a video of it, but you can sort of imagine this moving machine there. And this is an analogy of the bureaucratic machine. Although in Weber's sense, the machine was actually composed of humans. So it wasn't an actual machine. It was an organization where there are many humans working inside that organization that together form this administrative machine. And according to Weber, there are a few key features of the administrative machine. This is, of course, a bit of a simplification because it has to fit on one slide here. 5 key features are the rule-based rationality. That means that actions are predictable because they're guided by rules and procedures that are predefined. Hierarchy is the second feature. There are very clear chains of command, and the higher offices supervise the lower ones. Technical expertise is the third feature. That means that the people who work in the administration are selected based on their competence, and they're also trained if they need additional competencies. Procedural consistency, of course, a machine is consistent. It always does the job in the same way. So it's standardized, processes are standardized, and through that standardization, you can achieve uniform treatment of the individuals that are at stake. And impersonality, the decisions taken by the administration should be impartial, they should be fair, and they should be free from personal bias. And why does that still matter today? I mean, today we're no longer talking about reforms such as new public management as much. We talk about governance, we talk about agile, but the reality today, especially in Europe, is that there's still a lot of Weber around in the administrations. If you work in an administration, you will probably agree that these key features, they still exist. And I must say, even inside our university and within our institute, these are important principles still today. So Weber is still alive in that sense. And of course, there is a link, and I'm sure you can already start to see it, to AI agents. And if you haven't heard this term of AI agents before, I brought a definition here from NVIDIA. AI agents are advanced AI systems designed to autonomously reason, plan, and execute complex tasks based on high-level goals. And there's a key difference here to what we're using today when operating with ChatGPT and other large language models, and that's the execute bit. That's the really most important addition if you compare agentic AI and AI agents. I'll talk about the difference between those two terms in a bit with today's large language models. So NVIDIA claims, and I don't want to make this a marketing presentation, but this is actually a good website that they have here, that AI agents are the new digital workforce working for and with us. And they say it's the next evolution in AI, transitioning from simple automation to autonomous systems capable of managing complex workflows. And they don't only automate repetitive tasks, but also empower individuals to operate more efficiently by acting as a sort of co-pilot. So that's the take of NVIDIA. And moving over to another big player in the field, OpenAI. Of course, I will later also take a critical perspective on these large American corporations. They say that AI agents are one of the steps towards an artificial general intelligence, so sort of super intelligence that will be smarter than all of us combined. And they also say, if we believe this Bloomberg report here, that we're certainly not there yet, but they're working towards this sort of model where they have 5 levels. Level 1, chatbots, that's basically today's world, or somewhere in between level 1 and 2. So chatbots, they have natural language processing capabilities. Then we have reasoners, that's human with AI levels of problem solving across a broad range of topics. And then we have AI agents. Those are AI systems that can take actions independently from human instruction or following human instructions. So both is possible. It doesn't take the human out of the loop. But agents are, and they insist here on the same important difference. They can take actions, and that's very important. And then level 4 and 5, they're still a far cry away. Innovators, so AI starts to really act as an innovative force, contributing to human knowledge. And level 5 is the AGI. Then basically we can have AI create their own organizations that will work without any human input. That's still very far away in my view. But AI agents are not that far away. It's still not a reality everywhere, but it's something within reach within the next few years. I will be drawing in my talk a bit from a paper that my colleague Charmaine, who's probably also on the call, there's so many of you, I can see her right now, but she must be on the call, and I are working on right now. It's currently under review. I won't say where, and it's not perfect. So this paper hasn't been peer reviewed yet. But in this paper, we say that an AI agent is an autonomous digital entity composed of interrelated components that enable perception, reasoning, memory, and action. Actually, we draw in this paper on a Hertie fellow who I'm not sure is in the call or not today. His name is Deng. I think that's the last name. And we break, of course, down a bit this concept of AI agents to the public administration context. And we introduce one distinction that we think is important between AI agents and agentic AI. They're related concepts, but they're not entirely the same. In our view, AI agents are autonomous software programs that perform specific tasks. So an AI agent, as you can see here in the example, for instance, would be processing a benefit application from a citizen and judge whether the citizen is eligible or not for the specific benefit. So there's an input, a benefit application from a citizen. Then the AI agent would process this application, would screen it, would contrast it with the existing rules, and would then take a decision whether the citizen is eligible for this benefit or not. So its output is basically a decision that then a human can take and go forward with it. So it's pretty automated, but it's still very narrow in the sense that it performs a specific task and not multiple tasks. And that's what sets it apart from agentic AI. Agentic AI is basically multiple of these AI agents taken together. It's a system of multiple AI agents that collaborate to manage and achieve complex administrative functions that are enshrined in policy processes. That's what we sometimes call agent orchestration. And I think this is where it becomes really interesting. So in this example, we still have that eligibility chatbot, eligibility agent on the lower left, but we have other agents as well that perform other functions that are necessary within the entire end-to-end process of the application of the citizen, up to another AI agent that uses certain interfaces to pay out a certain sum to the citizen if that's necessary. And of course, these chatbots, they need to collaborate together. I say chatbots, it's mostly chatbots in this example, but it's AI agents. They collaborate together to create an end-to-end output on this process. There are a few other features that set these AI agents and agentic AI apart. I've already told you about the definitions of the two terms. The autonomy level is for the AI agent, the more specific one, is high, but only within the specific task, wherein the agentic AI setup has more autonomy on a broad level of topics, and of course also deals with more complicated problems. So task complexity is higher in the agentic AI setting than in the AI agent setting. Collaboration is another dimension. The AI agent is basically a separated box that operates independently. It's a module, whereas the agentic AI, well, that's really multi-agent collaboration, information sharing, and also interacting with pre-existing systems. So that's much more complex in terms of collaborating, and that also might include collaborating with humans, not just other machines. And then learning is, of course, also dependent on the setting. So an AI agent will mostly learn about their specific domain, whereas agentic AI really needs to learn about the bigger picture as well. How does this work if you zoom into the agentic AI? Again, here with an example. So you have maybe a user input, a prompt that's made by a human or another AI agent that goes to the agentic AI system. And within this system, there is an AI agent that is sort of the control center, the brain and memory that processes this information, that also interacts with maybe multiple other AI agents, the payment agent, maybe another agent that looks for fraudulent behavior. And it also can interact with the environment. And this is very important because this is what enables the take action part of the agentic AI. So it can also interact with physical infrastructure, for instance, in smart cities. It can access databases. Well, that's very dangerous as well, because if the agent accesses databases, then who's in charge of the data in the end? Will it delete the data at some point? So that's a cybersecurity risk as well. It can draw from different sensors, and it can, of course, also act. So it can generate a report, it can generate a PDF document, it can generate a podcast, whatever it is. And you will be pleased to learn that there in this lower left-hand box, you can also hook up a fax machine if you absolutely need to. So legacy systems are also possible to connect to the agentic AI. Now, agentic AI doesn't mean that the human is completely out of the loop, and that will not be the case in the beginning, and it isn't today. So again, another model of the levels of automation and human AI collaboration that we're using in our paper is basically that we say it all starts with a close relationship where the human and the AI work together. And the first level basically means that the AI will offer a decision or propose a few options that the human can then review and decide which proposal it would like to use and go forward with. The second level is then already a bit more automated. There, the AI can directly execute specific functions with human approval, but the human is still fully in control. It can veto any decision, which is also the case in the third option, although there it's even more automated in the sense that if the human doesn't veto, the machine will just go forward and carry out the action. That's all co-pilot mode, the levels 1 to 3, whereas levels 4 and 5 is what we call autopilot. So in level 4, the machine or the agentic AI would execute a specific task and then inform or execute in a fully automated way and not even informing the human. And this is basically a full replacement of the human in a specific process. It doesn't mean that humans will be replaced throughout an organization, but it means that certain tasks might no longer need the input of humans, which means that frees up capacity for more complex tasks that can be done by humans instead of machines. It keeps on beeping here because so many people are in the waiting room. So there's really a big interest in the talk, I guess. And now the next question that we're looking at in this paper is, okay, so if we accept that agentic AI is an interesting technology for public administration, then how should we go about the adoption of it? And what would be factors that we can use in our argumentation that we should adopt it, or that would help us to be cautious about certain aspects of it? And a model that we're using in this paper to assess agentic AI as a technology for public administration, its potentials and risks, is the technology affordances and constraints theory, which serves to study how people and organizations use information systems and how the use of information systems affects individuals, organizations, and their performance. Because in the end, we're always interested in how can this new technology help us to improve efficiency, effectiveness, and other important measures of performance. And affordances are understood in this model as what the technology enables in a particular organizational context, whereas constraints describe what limits or prevents its effective use. Now, if we apply this framework to AI agents and agentic AI, now I cluster them a bit together again, then we thought that important affordances of these new technologies are, first of all, process automation and procedural consistency. And this will ring a bell, of course, because it links back to Weber's administrative machine. With these technologies, you can automate administrative processes with precision, which was a word that Max Weber liked a lot, and uniformity. You can reduce human error and variance. Well, potentially you can. And you can strengthen standardized rule execution across multiple cases. So that's a big affordance, a big potential of this technology. Linked with this first point, but going a bit beyond it, are efficiency, responsiveness, and scalability. So using agents can basically accelerate administrative workflows and service delivery. Keep this in mind. I will come back to this responsiveness idea in my conclusion, but because I think it's very relevant if you look at some of the research that's been done on what citizens expect from administrations in 2025, basically. So they would enable real-time responsiveness 24/7, which is really a novelty in my view, because if I go to my local administration here in Switzerland, and I live in a rather small municipality of like 6,000 inhabitants maybe, they will be open 3 days a week only during office hours when I work somewhere completely else. So it'll be really hard for me to even reach the administration. And using these technologies can make the operating model 24/7, 365, which is, in my view, a big, well, improvement, at least for certain tasks that can be taken over by the agent. That also, of course, enables scaling. We often see staffing shortages in administrations. And here, with these technologies, you can basically potentially overcome these issues by scaling processes with agents instead of human workforce. The third item is empowering more meaningful human work. And this is extremely important because I'm not making a case here to get rid of all the human staff. Absolutely not. The idea is to relieve civil servants from repetitive tasks using agents. And by doing that, humans will then have the capacity or the time to do more complex and judgment-based and relational work, which is also very important, which can be done as well by agents. And then another aspect that we thought was interesting was that the agents also have some sort of hierarchical orchestration and basically also the bridging silo function built into them. And that again links back to Weber's idea of hierarchy. Agents also have a sort of hierarchy. And the higher order agents will coordinate the work of subordinate agents, and they also will have to talk to agents that are maybe in a different silo. Now, that's a big issue that we see across the board in public administrations today. There's not enough communication and coordination across silos, and AI agents can probably also help improve that issue. The algorithmic structures that would follow from the use of these AI agents would echo the Weberian hierarchy, but that's not really a surprise because it's also built on the rules that are the basis of our administrative systems. And then I also had a thought, if we introduce AI agents and they can do so much of the coordination work and management work, maybe in the future there will be also fewer need for managers, so fewer management layers. But I put a question mark there because that's just a thought for now. We don't have any empirical data to back that up. So that's the bright side, the affordances of agents. Of course, there are also constraints, and neither of these lists is complete, by the way. This is just conceptual and what we thought was important. An important constraint is, of course, the opacity that comes with any AI system, basically, which creates then potential accountability gaps. And that's a conflict with Weber's model because accountability is extremely important. And the black box AI models, they limit explainability, and in that sense, they also hinder oversight. Yesterday, there was the German-French meeting of governments, I believe, as I saw on the media, and they've talked about the big topic of digital sovereignty. So basically reducing the reliance on American and Chinese big tech. And I think that's also an important point worth mentioning, that the dependence on proprietary systems threatens this digital sovereignty. So right now, clearly China and the US are a bit more advanced when it comes to creating, developing, deploying these AI systems. And there's a temptation sometimes in administrations in Europe to just buy those systems and use those systems, but that has implications for our European digital sovereignty. And I think we need to really make efforts to become better to create our own systems. I have a few positive examples on my conclusion slide on how this could work. Weber talked of the administration of bureaucrats as part of a machine, but that doesn't mean that he wanted public officials not to have any discretion. Quite the opposite, actually. He said that discretion was an important element of the power of people in the administration. And that's something that algorithms may not be as good at doing as humans. So they may lack contextual judgment and nuance. And if humans and machines work together, there's also a risk of automation bias. So if we put a human in the loop that should control these contextual things, automation bias is basically a bias that would, over time, reduce the attentiveness of the human and create a tendency toward just accepting what the machine proposes, which is a risk and would reduce human oversight in a way that's not intended. The third point is infrastructure and organizational constraints. It's probably also one of the most important ones. So we need, of course, if we want to introduce and adopt AI agents, high quality data. That's not a surprise. We need interoperable systems, and we need integrated processes. And there, again, especially in countries like Germany, Austria, and Switzerland that are rather decentralized and federalistic, I see issues with process management, especially if you consider that a lot of the administrative work takes place at the local level. That's really where the interactions between the state and the citizens happen for the most part. Oftentimes, there's not even expertise to create sort of a business process model of the organization, a business process landscape. And if you have poor knowledge of your own process landscape, then it will become extremely difficult to deploy AI agents, because you need to really know what your process landscape looks like before you try and plant an AI agent into that landscape. So decentralized structures might be another hindrance in this aspect. You will also have a lot of legacy systems typically that the new AI systems will need to interact with. You will have to create APIs, so links between the old and the new systems that allow you to overcome or to enable the communication between new and old systems. And of course, there are workforce shortages in IT and considering AI skills. And also the pay tends to be lower in public administration, which would make this problem even worse. Another important constraint is that these systems may be prone to bias, may reinforce inequities, and may call into question legitimacy. So garbage in, garbage out, you know this principle when it comes to data. If you have biased data sets, then your AI agent may also end up being quite biased. You may have an issue called function creep as well. So if you have an agentic AI system that you give to a person in administration, that person has bad intentions and uses the system beyond the actual scope for purposes that are not intended by the law, for instance. That's what you would call function creep. Just because you can do something with a technology doesn't mean that you necessarily should do it. And if you cross that line, it might absolutely undermine trust in the organization. And if you have failed or controversial deployments of such agents, it may also erode administrative legitimacy in the long run. And the last point, of course, there are regulatory barriers, data protection, AI Act, cybersecurity issues that need to be taken into consideration. And you may also have quite a bit of organizational resistance when trying to adopt AI agents because risk aversion, of course, you don't want to lose your job. AI literacy might be low. And these are all important issues to consider. Now, a few examples before I end in a few minutes. I'm not going to go into all of them here. Education. In China, there's a case that we found, agent for education for tutoring, student support, study support, and administrative assistance. We have some cases in healthcare. We have some cases in public service delivery. Here, a notable example from Switzerland, the Swiss Federal Railways. In their customer service center, they already use LLM-based chatbots. That's not a novelty anymore, but they're now also moving towards AI agents in their customer service that could not only give information to the customers, but also act. So for instance, cancel a subscription or sell a ticket, things like that. We have an example in disaster response in the US, and we have multiple examples in Singapore, the Netherlands, and Spain on various urban management tasks, traffic management, energy management, waste collection. And let me show you one example here. I brought a little video of an AI agent, of an agentic AI system that does traffic management. Now, this is actually not by a big US tech company. It's by an Israeli hardware company. And they put this video on their website, and I found it quite interesting. It's an AI agent monitoring traffic and understanding the scene. It found a road hazard here. And now it triggers events as well, and it coordinates with other agentic, with other AI agents. So you can see here, it detected a road hazard. It created a plan, what should be done. So contact 911 emergency services, to basically the police, to go on the scene. And they also contacted 311, which is a service where you can report damages in the infrastructure, so they will get fixed. And it directly contacted these two other agents, and they also triggered certain events, so the problem would get fixed automatically. This is just one example of what's possible today. By the way, this is an edge AI case, so this is not on a large US server somewhere. This can be done on a Raspberry Pi if you want. Now, coming to my conclusion, the big question was, is agentic AI an upgrade to Weber's bureaucratic machine? And I think the answer is yes. AI agents extend rather than replace the bureaucratic model of Weber. They're compatible with the key principles, and they might even reinforce them. I've mentioned them in the beginning. I won't repeat them now. And they do not take the human out of the loop if we don't want it to. So co-pilot mode is possible, but autopilot mode is also a possibility for certain tasks. We've looked at the affordances, so the potentials for benefits in public administration, efficiency gains, increasing administrative capacity, mostly through automation, especially when you have high volume routine tasks and data-rich domains. But the benefits depend on data quality, infrastructure, and the institutional readiness, of course. If you want to adopt, however, the challenges are quite substantial. It's not an easy thing to do. We've talked about the ethical issues, opacity, accountability gaps, big tech dependence, and especially in the German-speaking countries, we have this issue with, I mean, federalism is a great thing, but we still have this issue that if we have 2,000 municipalities in Switzerland and every single municipality wants to create their own agentic AI solution, that's going to be extremely expensive and the outcome is not going to be great for the most part. So decentralization and federalism are a challenge to robust large-scale solutions and also to digital sovereignty. My overall conclusion would be that agentic AI represents an incremental upgrade to Weber's machine. It doesn't completely revolutionize things, and it could be used to strengthen public administration if it's embedded within robust governance and institutional capacity. What's also an important thing, and this is my last slide, is a connection to a study that's been done by some colleagues 2 years ago that looked into core values for ideal civil servants. And this study was very interesting because it was done in 3 different cultural contexts in the US, in the Netherlands, and in South Korea. And the main question was, what values do citizens expect from public administration? The results were very consistent across these 3 cultural contexts, and the top 3 results were service orientation, serviceability, responsiveness, and dedication. And the top 2 ones, serviceability and responsiveness, they resonate a lot, in my view, with the idea of automating administrative tasks with agentic AI. So in my view, there's also a large potential that agentic AI could increase citizen satisfaction if it's used properly. That's my talk. Thank you so much. I also have some future research directions, but I'll save those for the discussion. Thanks so much.